Hi, this is Don from NASA JPL, and in this video today I'm going to be running a brief overview of the performance respirator design developed under a 3D printable respirator project as part of JPL's COVID-19 response initiative. So with this design, I'd like to at this point out one of the big things that sets us apart from many other 3D printed respirator projects, and that is that we've gone ahead and tested our respirators throughout the entire design cycle. So as soon as this first iteration was complete, it was hooked up and tested to find quantitative fit scores. And we were lucky enough to be able to team up with our occupational safety office from the very start of the project to one, get their input on how to go about running this test procedure and the process, but also get a hold of effective equipment for doing that. And specifically what we're using is a TSI PortaCount Pro to measure the fit score results for all of these prototype masks. And you can find all that data up on our GitHub, actually for almost all the version iterations. So you kind of can see the progression of how different versions and changes performed. So we went ahead and tested this, and to give you an idea on fit scores, if you're not familiar with them, the fit score is a measure of how well the mask fits your face as well as the filtering capability of the mask. And generally for either a half-face respirator or an N95, the bar is you want a fit score of 100 or greater. And what that indicates is that you're filtering out about 99% of the particles in the air. So when we tested these masks, for instance, we would see fit scores up in the 1,000 plus. So we knew at that point we had an effective fit on their face, and we started shifting some of our focus to additional features. And that's what came to our next design iteration, in which we attempted to attach an exhaust port. So you'll notice most of these elastomeric respirators are meant for industrial use, and they all have exhaust ports on them. And the reason for those exhaust ports is it simply makes it easier for the user to breathe and prevents humidity buildup inside of the mask. And the reason for that is this exhaust port is simply a small flap that allows exhaled air to leave the mask without being filtered. And again, that works great in industrial settings, but when looking at a medical setting, that actually causes big problems because now the mask is protecting you from outside air because it is being filtered, but it just does not protect those around you from yourself. So if I am wearing a mask with an exhaust port and I am infected but I don't know it yet, if I cough or breathe out, that air is able to simply leave the mask and can infect those around me. So we quickly learned this when talking with some local medical professionals, and we began work on this. We learned we don't want to add it for this application, so we simply removed it. So you won't actually see it in your designs, but that's one of the reasons why they don't have exhaust ports, even though a lot of commercial versions do. Is for medical application, you want both the inhaled and exhaled air to both be filtered. So after that, we looked at another case where we simply took the filter medium that wasn't like a normal off-the-shelf P100 filter cartridge or P99995, but we took an actual just filter medium, and this is similar to many of the other designs posted online, where they simply clamp a filter medium on the front of the mask with a relatively small area and use that as the filtering element. We quickly found while doing that was not an effective approach, and that's because the filter area provided is simply too small for the alternate filter mediums that we are using. Either A, it makes it very hard to breathe if you're using a proper HEPA cloth or HEPA paper, or B, if you're using something like a MERV 13 or a MERV 16 HVAC filter, it simply does not provide effective filtering performance. So for instance, this mask here has a MERV 13 HVAC filter material mounted into it. We ran tests on it, and we would get fit scores on the order of like 5 or 10. That's a far cry from the 100 that we really are looking for. The other note I want to say is you might notice this hole in the top of the mask. This hole is actually there for hooking it up to the test equipment. So there's actually a measurement probe port for the PortaCount machine to take an air sample from inside the mask. So no, that's not there for common use. That's actually there for our instrumentation to take fit score measurements. So after we learned from these two sidetracks that these approaches weren't particularly effective, we went back to the original design and looked at simply making it as small as compact as possible. And that's what you'll see, a slimmer version located here. And if I line it up with the original, you'll notice it's much thinner. It also printed faster as well, and used these modified TPU seals that you can easily print on your 3D printer. And again, these masks performed in that 1,000 range, so we were happy with them. At this point, made a few samples, sent it out to some local medical professionals to solicit feedback on fit, form, performance, usage, and any other information they could provide back to us. And that's when we got the very interesting feedback, and what led into a complete revision of the design, which is what you see in my right side here. So the two big notes that we heard from medical professionals was, one, this design wasn't particularly adaptable to different face shapes or geometries. So unfortunately, this was designed and molded to fit for my particular face shape. We use it on others. For some people it worked, but for many other people it did not work too effectively. So that was the issue number one. The issue number two, which is somewhat related, was that because this was so stiff, if I go ahead and try to bend the bottom, it doesn't flex very much. That's due to this rigid section being so large. It made it very hard to speak, as it constricted your chin and your facial movements. And that was our main issues with this design. So we went back into the think tank and came up with what we thought was a very good solution for it. And that was to re-engineer this flex section to be longer, so it is one taller. We also created a flat section on the front face, so where this has a nice contour to it, we changed it to be flat. What that flat change allows us to do was to not print the flex section only in this orientation, but to also be able to print it in that orientation. And the reason why printing it in this inverted orientation was very important and impactful was that we were able to effectively create this internal flap geometry as a V. So it started at a thin base and would print out two walls, and that kept the print very clean, printed fast, and was simply easier to draw as well. So once we had this updated flex section, the next was to look at the rigid part. That rigid part we shrunk significantly. We developed it to the square profile, which was important in that, let me actually grab this one, in that it allowed the mask to effectively flex. So if I'm speaking, I need to stretch the mask, it will flex around that square profile and cause the two edges to bend inwards. So it allows rather significant flexing of the mask while compressing the sides, and this allows it to conform to your face as you speak. So as I talk, the sides will push into my cheeks and maintain conformation to your face, and thus a good seal on your face. The other big change we made was for the rigid section. One, it got significantly smaller to make it easier and faster to print, but two, it was now modular. We looked at both an approach where you can set an adapter plate to allow it to work with either commercial filter cartridges, such as the P100s from 3M, or custom filter cartridges like the one I have in my hand here, which we developed, that has a 3M adapter. So either one of these can slot into that front plate and be attached. So this front plate, the big thing to note is that it can easily be changed. So if you have cartridges from North or Scott, we can change this attachment point to be adaptable to those cartridge types. So now you can create a mask that you can easily swap this front plate on and make it work with any available cartridges on the market. The other note too was it was designed to simply slot into this flexible section here, and this was to, again, we're fitting along that adaptability thread, where now we can go ahead and swap these front plates for different versions as the situation demands or your particular needs dictate. And I can go ahead and put on the cartridge. So now I have an updated version of that mask with a custom filter cartridge directly mounted on the front of the flexible section. The other big change that we made too, that we think makes this very usable for general use individuals or applications, is that we can exchange the front plate for a directly integrated filter cartridge. So if I don't want to have all this extra filter cartridges, or I want to reduce the size as much as possible and I want to reduce the print time, I can pull that plate off and use our integrated filter variety. So this is a version of integrated filter where it takes this front plate and designs a pleated filter directly into it. And you can probably see from the back side these slots, and inside these slots was this white material that is a HEPA cloth from a Kenmore vacuum bag that we found to work very well. This particular slim version of the design houses about 98 square centimeters of filter material. We've also developed thicker versions, such as the one here, that you can see it's slightly bigger. This one houses 148 square centimeters, so you get about 50% more filter area. That makes it easier to breathe. But it's up to you which version you want to use. They're both posted up on our GitHub. And this works just like that front adapter plate, and that it slots directly into the flexible segment without much issue. There we go. So now we have it mounted on our mask. And now this has this compact integrated filter cartridge that makes it, to be honest, at the end of the day, very similar in size to your standard N95. It is still slightly bigger, but part of the goal with this configuration was to compact it as much as possible and make it seem like you're wearing an N95 and not intrude on the user. So the last thing I'd like to mention in this video is we have these two different configurations, but we also have been continuing to make updates to it. The most recent update to this filter cartridge design that we've worked on is in response to feedback we've heard from local medical professionals that have told us that it's difficult to speak through these masks. So they've had issues with patients having a hard time hearing them when they're wearing one of the masks because their voice becomes too muffled or too soft. And part of that muffling is because this filter medium causes any sound waves from your voice to travel through the filter, hit this front plate, and then have to bounce around and exit out the back. And it really does muffle your voice and makes it harder to understand. So to combat that, what we've done is added what we think is a rather unique solution, in that we've added this thin wall diaphragm on the front of the cover for these cartridges that's allowed to vibrate as you speak. And what's cool when you're wearing one is you can actually talk and put your hand up against it and feel the vibrations in this thin plate. So I'll go ahead and hit it with my finger, and you can hear this teeny sound. It's kind of like a drum skin. And what that does is, as you talk, like I said, the sound waves from your voice will resonate off this plate and cause it to translate out through the front of the mask more effectively, and that greatly reduces the muffling in your voice. So it doesn't improve the amplitude or the sound level of your voice, but it does make it much crisper and easier to understand. So we think that's a very unique contribution for our mask that I haven't seen on any others. And we're continuing to try to make improvements like that as we go through the project. So please go ahead and check out our GitHub page and our website link that I have down below. Check in periodically, because we have been making updates like that. We usually tend to try to drop a content update every week or two. And the other big thing I'd like to note is that these projects are designated as being open source. So we're highly accepting outside community feedback. We want to hear from you, either comments on what works, what doesn't work, what you think we should add. If you have things that are causing you issues, please let us know. Post an issue thread on the GitHub. The engineers are all there, and we'll likely try to respond to you and correct that issue, or at least post an update to explore the idea. So please be active, help provide us feedback. It can only improve the project. And everybody stay safe out there. At this point, I'm going to end the video, and thank you.